We are now in the era of information flood. And when there's a flood, often the light and cheap things float to the surface. And this time they are in the form of quick fixes, flashy headlines, and half-baked explanations to any given question. Meanwhile, the weightier and the stuff of gravity in the form of thoughtful efforts tend to settle beneath. They are ignored and overlooked. It seems like we are living in the era where there is a race to shout, "Me first," especially in delivering solutions to the students. And in this scenario, the deeper and more sincere efforts are often sidelined. Here is another question from JEE Advanced 2025 sample paper, as you can see on your screen. And I have seen the solutions floating around on YouTube, and honestly, they are not quite up to the mark. It almost feels like the teacher already knew the answer and then tried to reverse engineer a justification around the answer key, even if it sounded illogical. They are trying simply to build up the argument around the known answer key. By the way, I didn't stumble upon these videos myself. A student of mine sent them to me with timestamps of these questions. So this is the one question I'm discussing today, and yesterday I have already discussed one problem. Both the questions have not the solutions given up to the mark in the videos. But here we will take a different route. We will go very slow and understand everything step by step. Because I believe in the pursuit of truth, speed is not the goal, the clarity is. So let's discover. Alright, so this is the question we have, and the question says that there's a region S, which is the grid n by n, and Sn be the set of points x, y belongs to S, where x, y, and n are integers, and let Ln be the set of all lines passing through at least two distinct points from Sn. Suppose we choose a random line L from Ln, let Pn be the probability, and so that the L is the tangent to the circle. So the thing is, first of all, we have to understand what the question is saying. So the question simply says that I have a grid n by n. So let's say I have n by n grid, and in this grid there are some integral lattices. You know that this kind of questions we have already done, that integral lattices. So there are some integer points, and maybe you are connecting 2 points integers. You have to only connect, see, they're passing through at least two distinct points of Sn. It means it should pass through, maybe let's say this integer points, at least two they are passing, or maybe it also can pass in this way, we don't care. So, and you are drawing a circle corresponding to this n. So maybe the circle you are drawing here, so in that case one tangent is there. Maybe circle you are drawing in this way, so you're drawing like one tangent also here. So suppose I have this case, so we can have one tangent, and there are as many lines you can pass through the two integers of this lattice. So there's a one tangent, this is counted as one line, and there is a other lines can be drawn, so there will be number of sample space, so the probability will be counted as 1 by that total number of lines of such kind. But it is for n actually, and it's not for n is equal to 1, 2, and 3. It is n tends to infinity. That probability you find, and that will be the answer. But first of all, we have to understand how this geometrically possible, and maybe we can structure this kind of thing or not. So let's start thinking, and then we will count. So the idea is that suppose I am substituting n is equal to 1 in this equation of the circle. we have to draw the circle for n by n grid in every case. It means for n is equal to 1, we will draw the circle for 1 by 1 grid. So 1 by 1 grid will be there. I have already drawn for you. So you can see that I have taken this thing as 1, 0, and this is 1, 1, and this will be 0, 1. In this way, you are thinking that these two tangents are possible, and this is 0, 1 and 0, 1 only. So of course I don't have other lines here. Maybe this line and this line we can count because it's also satisfying the condition. So in this way, we have to, if we have to find the probability, we can find it. But we don't have to find in this case. We have to find for n case, actually the case for n. So for that, we have to think how the circle will look like when we increase the value of n with respect to the square or the grid with a structure around it. So for that, let's see how we can think. Suppose you have a circle here, and the circle equation is already given. I have x square plus y square, n square, 1 plus 1 minus 1 by root n, the whole square. So the thing is, how do we know that the grid will be there? So first of all, we have to identify whether the value of the radius is higher than the value of n or not. If the value of radius is higher than n, then our grid will look like this, or maybe it will look like this. So there are only two possibilities. If I'm saying that if r is greater than n, then in that case you can draw the grid either like this, or you can draw the grid either like this. By the way, these two lengths will be equal. So in both of the cases, you can see that there is less chance to get tangent. In this particular case, when it is like this, we don't have any chance to get the tangent until this point is the integer point. But of course, if the point is integer, there is no chance to get another integer in the region, because region is already inside it. But if you are drawing the grid like this, there is a chance, because in this particular region we may have such points, we don't know, which will be the tangent to the circle. So this is the whole setup. So let's compare the r and n. So you notice that this value I can assume as r square. If this is r square, I can expand it just to see what is going to happen, and this will become n square plus 1 minus 1 by root n, the whole square. You can notice if this is r square is greater than n square, because we are adding something extra to the n square, of course the r square will become greater than n square. So if r square is greater than n square, I can say directly that r is greater than n. It means the grid I am looking for must be like this, let us assume, because I don't know whether this is here also. So let's say these are two possibilities of the grid. Okay, now how do we know that this possibility is there or this possibility is there? So for that, let's try to solve the equation of circle with this line. Which line? I'm assuming this line is what? X equals to n, and you can notice this line is y is equal to n. So if I just solve it, we can get some idea how we can get it. Let's see. So I'm intended to find the y value, means this value, this length. So let's put x equals to n. So let's put x equals to n. So what will happen? You'll get there y square is equal to n square, and this is x is equal to n, so this is also n square, and times 1 plus 1 minus root n square. You can notice what will happen if I write n square plus y square is equal to n square plus n square 1 minus 1 by root n square. This n square will cancel, so we have y is equal to n times 1 minus 1 by root n. This we can also write as n minus root n if you multiply. Now see, it's a very wonderful thing going to happen. What is going to happen is, since I'm saying that this is n comma n, which I'm saying n comma n, this point I'm calling it n comma n, and you are subtracting a very small quantity from it, you can never fall on n minus 1. Are you understanding what I'm saying? Because their intersection is n root minus n, minus root n. So it means that this part is never going to happen. Means this scenario is never going to happen. Why? Because this much length is n minus root n, and since the x value is same, so this much length is n minus root n. Here this much length is n minus root n, because the y value is n minus root n. And so whatever the part left out here, this part is just root n, this part is just root n. It means we are seeing this arc here is always above n minus 1. And in the same way, if we are seeing this arc here is always above n minus 1 on the x-axis. So this is the last grid you found. This is n minus 1 and n minus 1. So this grid, this is the region I have in which this arc will lie. Below this region, there is no chance to get the tangent on the circle. This was the only left out region we had. There is some possibility for the tangent, but since this is the last region, we cannot have any line which is passing through two integral points. It means there is no chance to get tangent, so the probability Pn itself is 0. So Pn is 0, so the limit whatever you take, n tends to infinity, is 0. So this is my take on this question, and in this way we can clearly understand what is going on. And now I'm inviting you to let's deep dive into GeoGebra and explore more into this question. We will see everything in the animated way, and we will feel actually what is happening in reality, and we will see actually why I'm saying that some solution on the YouTubes are not that much satisfactory, and they are claiming wrong notions. For n is equal to 2, the circle is surpassing the square and this kind of things. In GeoGebra, everything is empirical, and you will see visually what is happening. Let's dive in. So we are in GeoGebra now, and we are going to explore this question in this graphical tool, and we will see how the value of n changes, and the effect of change in n will change whole scenario of the circle and the square, and in such case there is no tangent possible to draw on the circle. So for that, let me just first enable the axis. I have axis there, and I want to create a slider so that if I change the value of n, and automatically everything will change. So for that I will hit small n, and of course I have this slider on this screen right now. I can change the value of n because n starts from 0 and goes up to some large number. So n I cannot keep as a large number. So for that I'm going on settings, and there's a slider. On slider I want to keep the minimum value as 0. So I will input there 0 and hit enter. And the maximum value I want to keep as 100, let us say. So maybe the maximum value is 100. So in this way what will happen, that we can create the grid of 100 by 100. And increment I want to make it 1, because every time I'm increasing by 1 unit only. So this is the slider created, and on this basis of n I'm going to create everything. So now I had to create a circle. So for circle I want to create the right hand side of the equation x square plus y square is equal to a big expression. That big expression I'm going to call it a k. So k is nothing but n square and times, not there, it is down, so n square times 1 and plus, so for that I have a plus and then again bracket, and in this parenthesis I have 1 minus 1 divided by square root of n. So for square root I simply type sqr and it will give you the option. You will hit enter and you will have this square root at x, but I need there not x, I need there n, so I put n there and we go out of this inside parenthesis and again make a power of 2 because this is in the question. And after this, this is the value of k, so I'm going to draw the circle. The circle equation is x square plus y squared is equal to k. So that is k here, and we have this circle on this grid. Now when n is equal to 1, n is equal to 1, this is the circle I have, and you can notice that when n is equal to 1, this right hand side expression of the circle equation is also 1. Therefore the circle is of unit radius. Now I want to create a grid of n by n grid starting from 0. So for that I have a facility in GeoGebra. I can take polygon, so I call it polygon, and in polygon options you can see that there is an option of point, and number of vertices. So I have to select 2 consecutive points and just tell how many vertices or how many sides you need. So there's a number of vertices means number of sides also. So I will select 2 consecutive points. So because starting from 0 0, so I will select the first point as origin, that is 0 0, and the second point I can take because the second point is on the x-axis I can take, and that will indicate n 0. So I will call it n 0. I think there is one. Okay, so now I will take n 0, and in this third argument where they're asking the number of vertices, I will go outside of this comma and put only 4. So you can see that this grid is already created. It is calling poly, so I will just disable the name of it. So I will go to settings and there is a show label, so I don't want to show it. So you can see in this first scenario where the grid is 0 means 1 by 1 of 1 by 1, you can see there is a tangent possible because the 0 and n is already inclusive. So you can see that the 2 tangents are possible on the circle, and after that what will happen, you can just explore by just actually moving this slider. So I will just enable this thing to show you on this plane. So I will just enable it, and you can see that the same slider is here. So I can now close this thing. So I will close it, and now I will have this grid here. I can just make this slider move by just pressing it and sliding it right. So n is equal to 2, and you can see that, and n is equal to 2 only, this is outside of the circle. There's a one little chance there could be a tangent, but if you draw any tangent here, that tangent should pass to the 2 integral points. What will happen when I increase the value of n? Suppose I'm choosing this n is equal to 100 there, and I'm just making this smaller to show you what is happening. You can see that now it's very close to this n. So if you have n is equal to 100, still it is not coming inside it. But some video explanations are saying that is already inside. I don't know why. Now this is n is equal to 100. Suppose I make the value of this slider to 1000, see what will happen. So suppose I'm making the maximum value as 1000, hit enter, and I'm increasing this n to 1000, you'll see what will happen to this whole thing. I made this 1000, and again I make it smaller to show you what will happen. You can see that still there is a little extra area which is outside of this circle arc. It means if you take an enormously high, then only this will come inside it. So when n is equal to infinity, there's still no chance of it. But some explanation they are saying that for n is equal to 2 or n equal to 3 only, the square is inside the circle. So this is the whole thing I wanted to show you by exploring this question. And this question is actually not so difficult to understand in the first place, but it is actually worth understanding how the whole thing is happening. So that's all for today. See you in the next video in some other problems that I think you must try. Stay math active.